Kia ora Year 12. This is the complex numbers question from the winter 2015 paper, and I should have said on there that it's paper 31. So this is the question. It's got 3 parts and it's worth 10 marks. Again, I don't think it's too bad, not compared to some of the other ones we've been looking at lately. Anyway, so we're given a complex number 3 minus I, and then we're told that we've got its conjugate U star. So first thing we have to do is to draw an Argonne diagram and show these points, U, the conjugate, and the conjugate minus the original. Then we have to work out what kind of quadrilateral is OABC. So the first thing to do is to figure out what's the conjugate. So it's going to be 3 plus I. So working that through, we end up with 2I. So we now have to go and draw a decent diagram, and it's going to make life much easier as usual if we do a good one. So for once, I'm going to do a proper diagram with some straight lines. So this is point O, the origin. U is at 3 minus I, so that's down here. U star is at 3 plus I, so this is obviously highly dodgy. But there you go. I can't get Desmos to do complex axes. And the last point we've got is U star minus U, which is up here at 2I. So if we join those up, you're going to use a ruler to do that, and I am too. Okay, so you can see that what we've drawn there is a parallelogram. And back to the question, the next thing we're asked to do is to work out U star over U. We're going to multiply top and bottom by the conjugate, so we're going to rationalise the denominator, and that gives me 9 plus 6I plus I squared, so minus 1 over 9 plus 1. And that gives me 8/10, so 4/5 plus 3/5 I. So even before we go any further in the question, we probably are thinking, oh, it looks like it might be to do with a 3, 4, 5 triangle. And the last part of the question gets me to use that result to prove this, that the angle whose tan is 3/4 is twice the angle whose tan is 1/3. And we're going to do it by looking at the argument of this thing here. So we've just figured out that U star over U is that. So applying my standard definition, it's going to be B over A. Sorry about the background noise. So that gives me tan inverse of 3/4. Now, how are we going to show that that's equal to 2 times tan of 1/3? Well, we've got to remember that the arg of U over V is equal to the arg of U minus the arg of V. So the arg of the conjugate over the number is equal to this. Oops, that should be a minus sign. Right, now U star was equal to 3 plus I, and U is equal to 3 minus I. So that equals tan inverse of 1/3 minus tan inverse of negative 1/3. It's useful at this point to draw the tan graph and just have a wee look at it. And remember that tan is an odd function. So, since tan of theta is odd, or an odd function, the inverse function is also going to be odd. So looking at it, you can see that if we've got the angle whose tan is 1/3, takes me from 1/3 here down to here. And because of symmetry, which is what odd functions are all about, if I'm looking here at negative 1/3, you can see that that's going to be negative theta. Okay, so that means that I can say the following. And we're basically done at this point. So that's equal to tan inverse of 1/3 plus tan inverse of 1/3, which is 2 tan inverse of 1/3 as required.